So now in this video, we're going to come back to this circuit. I have a couple of MOSFETs here wired in a push-pull configuration. Ultimately, the output will be the opposite of the input. We have a high input right now and a low output. The blue LED is lit up. You can see that connection right there. The N-channel enhancement mode MOSFET 2N7000 is on right now because we have a high input, which also turns the P-channel enhancement mode MOSFET off right there. So the red LED is not lit up. Now I substituted the 220 ohm resistor for a 1000 ohm resistor like I did with the blue LED. So there you can see the red LED is not very bright. It's got, close to the same amount of current. Blue LEDs are just a lot brighter at the same current. But yeah, right now the P channel enhancement mode MOSFET's on and the red LED is lit up. We covered that in detail. Now some people asked, I got a trim pot here. So imagine instead of a switch from positive and negative, this comes to a trim pot to the wiper that can slide up or down, go up to 5 volts, halfway would be 2.5 volts, and down lower would be 0 volts. Now we have the red LED. I'm going to raise the voltage higher than 5 volts. That's why I got the 1000 ohm resistor like I do for the blue LED. I think we can go to 15 volts. I think the resistor will get, pretty hot at that voltage, but I think it'll still be okay. Now we got that trim pot, and there's the knob there, controls the wiper. We're all the way to the positive supply. So that's just like if I have the jumper right there. And it looks like it prefers to give a low input for some reason right there. And there we go. We go to the negative supply. And since they're MOSFETs, no current goes through the gate. It just looks at the voltage. But there we go. We got the positive supply. So somebody was wondering about a changing voltage, which is a good question. And this is, I haven't even tested this out for this video yet. This is something I kind of forgot, but it is a good thing to be aware of. What if we got just kind of a changing voltage for these two? So I can't remember what happens. But yeah, it looks like I got to go down there. So yeah, it looks like we have this small area where the voltage can be in a middle ground region. I'll dim the light so you can see that. So yeah, as long as we're within this small region right there, maybe they both turn off. We got a really low current right there. So yeah, that kind of tells me maybe current's just flowing through here. Maybe they're both off right now. That's what that's telling me. So it's kind of tricky to measure that. But in any case, we do have this kind of a fade effect right there. So if you really like that, you could set this up that way. So that's at 5 volts. I have current limited to 20 milliamps of current. Another thing people are kind of worried about is that both transistors would be on at the same time at any point. And if that were so, then it would be a short circuit. The power supply here has short circuit protection, and I got current limited to 20 milliamps of current. So let's put this to the positive supply. If I connect this jumper, that seems to be kind of a bad spot. So that's the positive supply. If I connect this to the negative supply, there you will see it said CC right there, and the power supply turned off. It might have been CC for a little bit. It was putting 20 milliamps of current, which is, fine by itself, but this saw that we had a short circuit, so it shut off. So something to be aware of. I just have to hit the power button and it will turn on again. So we have two ways to indicate a short circuit. First off, the output cuts off. That would actually be second. You'll see a CC right there first. This is limiting current, and I got 20 milliamps of current because that's the maximum you usually want to put through an LED. So I could just go up to 15 volts, but let's I just set the trim pot to the positive supply, and we got the positive supply right there. If I turn the trim pot to the negative supply, we would have had a short. So that's a goof on my part. I should have moved this to the gates, but I forgot to move it. So no big deal. That's another reason why I got current limited, in case I miswire things, like I just did there, where they cause a short. So high input, low output, we expect that. And it doesn't matter that we change the voltage right now. And you can see we did have, maybe they did kind of start conducting. Well, I changed the supply voltage. That's interesting. But we got 10 volts. Doesn't look like we're going to be able to go to 15 with these resistors. And I'm not sure. yeah, that's a lot of, okay, we got 10 volts across a 10,000 ohm trim pot. So that should be 1 milliamp of current going through the trim pot. So yeah, we have a lot more voltage, or a lot more current, I mean, than we want. So that tells me these are both conducting a bit. And I got a feeling if I lower this halfway, there we go, yeah, pretty sure that, yeah, now they're both conducting. So maybe not conducting perfectly, but yeah, 10 volts, you would not want to wire up this circuit like this. Limit it at 5 volts. So there's probably a way we could improve it where it could work at higher voltages, but for now, we're going to leave it at that. Don't do higher than 5 volts if you do this circuit. So that's something important to keep in mind. But always keep in mind, higher voltages often cause, I'm going to say problems, but they're not really problems as long as you know the solution, as long as you're aware of the issue. And then you got to find a way around it. Something to always be aware of. We could use a voltage regulator, so if the supply voltage went up, the regulator will keep outputting 5 volts. It's kind of like a, automatic resistor. It, limits current as needed to maintain a voltage at the output, and it creates waste heat and everything, but it's useful in situations like this where you got to keep an eye on higher voltages, and you don't want to convert the voltages because that would use even more power for a low power circuit like this. But in any case, yeah, just I could keep doing these little experiments like all day or whatever, and that's what you should be doing if you're learning electronics right now. You come up with ideas, test them out, but again, make sure you do it safely. Use a power supply that can limit current. If you use a battery, it may have protections for itself from short circuit, but odds are the battery can handle a lot more current than any of these components can. So you'll probably fry a component, which hopefully it'll stop conducting, and that'll protect the battery instead of creating a short enough to damage the battery if it doesn't have short circuit protection. But in any case, bunch of topics covered in other videos, and other people cover them as well. Be aware of that. But for now, I hope you enjoyed the video. Thanks for watching. Make sure you check out one of the other videos I'm posting on screen, and check out links down below. They'll help out a lot. I'll see you in the next video.